So today we are going to talk about the 4 teaks in Unit 7, which is our describing patterns and relationships and prime and composite numbers. We'll start by talking about prime and composite numbers. So I want to remind you first that our teak for 5th grade, 5.4a, is an identify teak. So the students just have to identify whether a number is prime or composite. That means all they need to do is find out if the number has more than one set of factors. So let's talk about what prime and composite means. Prime means a number's factors are only itself and one. Only itself and one. Composite is anything else. These are numbers or factors that are in addition to itself and one, which means if a number has any other factor besides itself and one, it's composite. So let's talk about some special cases that we have to pay attention to in 5th grade. Some important things to know. First of all, the number 1. It's not prime, and let's think about why. It's not prime because it doesn't have the factors of itself and 1. Its only factor is 1. So it's not a prime number. It's not a composite number because it sure doesn't have factors of more than itself and 1. Its only factor is 1. Kids tend to mess this one up because they think, oh, well, it's 1 times 1, so its only factors are 1 and 1. But that's the same number. So it really only has the factor of 1. It doesn't have the factors of itself and 1. So that's the key that makes the number 1 not prime, and we can see why it's not composite, because if it doesn't have more factors than 1, it surely doesn't have more than it would need to be a composite number. A second really important number for us to consider in 5th grade is the number 2. Number 2 is the only even prime number, and let's think about why. It's the only even prime number. So let's think about its factors. Its factors are 2 and 1. That fits the definition of only itself, 2, and 1, 1. Now, the reason we point this out in 5th grade and really talk about it is students tend to think, once they start thinking about what composite numbers are, they tend to think that all even numbers are composite because they all have the factor of 2. And that's true, except for the number 2. So it's a special number. It's the only even prime number. So we want to make sure we point out these 2 special numbers. Now, remember I said our teak in 5th grade is an identify teak. Now here's what that means. Students do not need to learn prime factorization in 5th grade. That's a 6th grade teak. They only need to be able to think about divisibility rules to see if they can find any factor besides the number and 1. So we think about divisibility rules in 5th grade because, oh, I almost spelled it wrong. Because that lays the groundwork for what we're going to need to do when we start simplifying fractions. So the numbers that I always talk to my kids about thinking through divisibility rules, 2, 3, 5, and 7. Those are the main ones, and usually you can decide if a number is prime or composite with what we do in 5th grade by checking the divisibility rules for these numbers. Here's why. If I know it's divisible by 2, I don't need to check 4, 6, 8, 10. If it's divisible by 2, those are taken care of because 2 is a factor of those numbers. 3, I can check easily to see if a number is divisible by 3. And there is on the Google Drive some divisibility rules to help you and to give your students something to put in their journal. So divisibility rules simply for 3 is if I can add the digits of the number up and that's divisible by 3, then the number is divisible by 3. So let's look at an example. If I wanted to know if 45 was divisible by 3, I would say 4 plus 5 is 9. Is 9 divisible by 3? If the answer is yes, which we know it is, then 45 is also divisible by 3. And we know 45 divided by 3 is 15. So then we can say, yes, it's divisible by 3. Let's check another one. Let's do 62. I don't know right off the top of my head if 62 is divisible by 3, but I know 6 plus 2 is 8. Is 8 divisible by 3? No, it's not. So then 62 is not divisible by 3. That's how you use that rule. We all know the rule for 5. If the last digit is a 5 or a 0, the number is divisible by 5. I'm going to tell you there's not a great rule for 7. There is a rule and it's crazy confusing, so kids just need to divide. If they haven't been able to eliminate it by this point yet, they just need to divide by 7 and see. Now, yes, there are other numbers that this could be, that some number could be divisible by. This just helps eliminate a lot of them, so it's a good starting place. So remember, it's an identify teak. I don't have to teach factoring strategies. I don't have to teach prime factorization. Those aren't my teaks. My teak is identify whether it's prime or composite, and we do that through divisibility rules. So let's look at the next teak. The next teak is 5.4b, and that's where we represent and solve multi-step problems with all 4 operations, making sure there's a letter there for the unknown. So I just grabbed one of the 2021 STAR questions to look at for this teak, and I just want to talk through a couple of things. Notice it's usually a wordy word problem because it's multi-step. The students aren't asked to solve this word problem. They're asked what equation would you use if you had to solve this word problem. So one strategy that I used with my kids when there was a lot of confusion around these answer choices that they were given is I told them, cover up the answer choices. I didn't cover them all. Ignore them and figure out how would you solve this problem. Then go look at the answer choices and see which one matches what you did. So we just treated it just like any other word problem, and then we went and checked the answer choices. That's a great strategy for students to use because we've taught at this point in the year how to break down multi-step word problems. So it allows them to use what they've already learned this year and apply it to this situation. The other way that this teak is set up is students will be given a really long wordy word problem, and then they're given the equation. And it might say, use the equation 90 times 36 divided by 6 to solve for B. They don't have to worry about anything in the word problem. They're already told what equation to solve for. They simply have to apply PEMDAS to it when that's the case. So if they're given the equation, they just have to solve it. If they're given a word problem and asked to find the equation, they're not being forced to solve it, but a good strategy is to go ahead and solve and use what they know about how to solve word problems to find what equation goes with what they're being asked to do. And then let's look at 5.4c and d together. And the reason we're looking at it together is these two teaks go hand in hand. So first of all, 5.4c is where students generate a numerical pattern. And I want you to think about all the ways they could be given a rule in the form of an equation or in the form of a graph. So they don't necessarily have to be one or the other. They might see a table, they might see a graph, they might see an equation. So those all have to work hand in hand. And then 5.4d asks students to recognize the difference between additive and multiplicative numerical patterns in a table or a graph. So let's look at this one first. Notice that in 5th grade, this is a one-step equation. One step. And that one step could use any one of the 4 operations. So it could use addition or subtraction. It could use multiplication or division. So we want to make sure we're exposing kids to all of those things. And just like we did when we were working on our PIMDAS unit, we want to make sure we're exposing kids to all the different forms that they might see multiplication equations or division equations. So we can't always just say it's going to use the division sign for division. And we'll talk a little bit about that in a minute. So this one is a pretty straightforward question. This one, students are just asked which table matches the equation in graph, which table represents the rule. What throws kids off is they think, oh, I have to find these points, 0, 5. Well, if I look down here, there's no 0, 5. So then they're going to say, well, there's no answer. But that's not what they were asked. They were asked what represents the rule. So they need to check every point to see if it represents the rule. We can tell easily that B is the right one because 4 plus 5 is 9, 5 plus 10 is, 5 plus 5 is 10, 6 plus 5 is 11, 7 plus 5 is 12. This table uses multiplication. This one started out adding, which if students do what students tend to do, which is check the top line only, then they might choose and think this is the correct one. But if you notice, the Y values are counting by 5s, and that has nothing to do with our rule. And then you can see on A, this would be x minus 5 instead of x plus 5. So let's talk about a couple of things. One, we want to make sure kids check every line of the table. That's got to be a rule. That has to be an expectation. Because you can see how this one alone would trip kids up in doing that. The second thing is we need students to make the connection of what the rule is between whatever the two columns are, whether it's X and Y, or there's an old star problem that was like markers and number of boxes of markers or something to that effect, like there's 8 markers in every box. Real world relationships. The relationship is between the X and the Y, whatever those happen to be, not between what happens as you move down the table. We're talking about the relationship across the table, not the sequence of the numbers happening down the table. So some other things we need to make sure in 5th grade is we need to make sure that students can write the rule both ways. And what I mean by that is, let's just focus on the right answer for a second. We know that the rule here is y equals x plus 5, right? I would like for students to also be able to say the opposite of that rule. Y minus 5 equals x. Now, it's not a big deal in this particular problem because it's just x and y. But there are times that this standard is tested with word problems and real-world relationships, like I mentioned with the markers and the number of boxes. So if I think about a real-world relationship like the number of legs on an octopus, every octopus has 8 legs. So my table, can't write on that anymore, it's got marker through it. My table could look like number of octopi, number of legs, right? And I know 1 has 8 legs, 2 has 16, 3 has, why did I lose count, 24, etc. 10 has 80, okay? I want kids to be able to say both rules. Both rules for this table would look like the number of octopi times 8 equals number of legs, or the other way, number of legs divided by 8 equals the number of octopi, right? Do you see how that rule goes both ways? It has to go both ways. So no longer can students just say the rule is times 8, which is what they did in previous grades. They just identified the rule going one way. Well, in 5th grade, when we apply this in word problems, I could be asked for the rule either way. I could be asked what's happening in this relationship either way. It doesn't have to be limited to one direction. So I want kids to write the rule both ways. Now, the second part of this that we're going to talk about is 5.4D, which is the standard that says students have to recognize if this is an additive or a multiplicative relationship. So if I go back to this problem, I could say that this is an additive relationship because it's either using addition or subtraction. So I want you to make sure kids understand that additive doesn't just mean I'm adding. It's adding or subtracting. In the same way, multiplicative, like the octopus rule, multiplicative uses multiplication or division because the rule can be written both ways. It's additive because I can write the rule as an addition statement, but I can also write that rule as a subtraction statement. Multiplicative, I can write the rule as multiplication, or I can write that rule as division. So I want to make sure kids know that additive and multiplicative, which is usually one of the simpler things for kids to pick up on, has to have both operations, so it can be either or. I would expect to see this tested with some of the new question types when we start seeing those on STAR, simply because it's been a really simple standard, and when you test it with multiple choice, there's only two choices. It's either additive or multiplicative. So it's easy to eliminate two of the answer choices. So this is usually tested with the pattern is additive because, with a different reason, and then the same thing for multiplicative with two different reasons. Well, if you can pick out if it's additive, you just eliminated two answer choices, and then you just have to look at the rule. So I would expect to see this tested a different way in the future, maybe with inline choice, or something along those lines. It could even be a text entry. So just keep that in mind when you're working with your kiddos. And as always, if you have any questions, let me know. Have a great day.